Okay, we're going to finish off our study guide. We ended last video with number 6. Now we're going to do number 7. Write the equation in slope-intercept form for the line that passes through 1, 6 and negative 2, 0. So we have 1, 6 and negative 2, 0. And we want an equation in slope-intercept form. So I have these 2 points. And we want an equation in slope-intercept form. Well, gosh, I don't have much, do I? I certainly don't have enough to put it in slope-intercept form now, but what I do have is 2 points. Wait a minute. If I have 2 points, we'll call this point 1 and this point 2, can I put this in the formula to find slope when we're given 2 points that are on the line, which is exactly what we were given? And I just labeled these points, point 1 and point 2, and that nicely fits into this formula. Y sub 2 is 0, and we're going to subtract y sub 1, which is 6, and then we're going to find x sub 2, which is negative 2, and we're going to subtract x sub 1, which is 1. Now we're going to simplify this. If I have 0 and 6 negatives and I combine them, well, 6 negatives combined with nothing is 6 negatives. And in the denominator I have 2 negatives and I have 1 negative. And if I combine all those negatives together, there's no positives. That's going to give me 3 negatives. A negative divided by a negative is a positive. 6 divided by 3 is 2. So 2, positive 2, is the slope. So now we have the slope of the line, and we have 2 points. But with point slope, we only need 1 point. So we can pick a point. Well, I'm going to pick this point because we already labeled it x1, y1. And my formula for point slope is y minus y sub 1. So I'm going to use that point right there, equals m, which is my slope, which we just figured out is 2. Nice m, huh? Times the quantity x minus x sub 1. And my x sub 1 is found right here. This is going to be a piece of cake. So I have plain old y minus y sub 1, which is 6, equals m, that's our slope, and when we did this formula here, we found the slope to be positive 2, times the quantity, plain old x, minus x sub 1, which I know to be 1. Easy, easy, easy. Now, this is point slope. I want it in slope intercept, so I want it to look like this when I'm done. So I need to get that y alone, don't I? So first I'm going to simplify the right-hand side using the distributive property, and I'm going to get 2x, and 2 times negative 1 is negative 2. I still have my y minus 6 over here. If I want to get y alone, I'm going to add 6, and I'm going to add it to both sides to keep my balance. And these cancel out. Y equals 2x. If I have 2 negatives and 6 positives, I have more positives than negatives. I have 4 extra positives left over. There's my equation. Now, just to show you that I'm not just making stuff up, I'm going to graph this equation. I'm going to begin at 4 on the y-axis. And my slope is going to be 2. Which I'm going to graph as rise over run 2 over 1. So I'm going to begin with 4, 2 over 1. So I'm going to begin with 4 on the y-axis, and I'm going to go up 2 over 1, up 2 over 1, and I'm going to go down 2 and back 1 a couple times also. So I get a nice look at what my line looks like. Okay, there's a nice straight line. If I connected those points, which I can't do because I only have 2 hands, and the 2 points we were originally given were 1, 6 and negative 2, 0. Well, 1 1, 2, 3, 4, 5, 6 is this point right here, and negative 2, 0 is this point right here. So hot diggity dog, this line contains the 2 points we were originally given, and this line is the graph of this equation, which we derived using these 2 points originally. Dang, we did it. We are good. Okay, number 8, very similar. We're given 2 points, negative 2, negative 1, and 2, 5, and we're asked to put it in slope-intercept form. It's worded a little bit differently, but it's asking us to do the exact same thing. So I started out with 2 points. When all I have is 2 points, and we're talking about linear equations and slopes and intercepts and stuff, wait a minute, 2 points can get me the slope if I use this tricky little formula right here. So I'm going to label these points x and y, x and y. I'm going to call this x1, y1, and x2, y2. I think I was sniffling in that other video. I apologize. I have allergies and it sounds awful. I hope I don't do it in this one. Now I'm going to plug these in. So y sub 2 is 5 minus y sub 1 is already a negative 1. So I'm going to subtract y1, which is already negative. So I'm going to subtract negative 1. 5 y sub 2 minus y sub 1 over x sub 2, which is 2, minus a number that's already negative, which is x sub 1, which is minus 2. Remember, when you're subtracting a negative, it's the same as adding a positive. So 5 plus 1 is 6, and 2 plus 2 is 4, and I better simplify that, and you know how I like to simplify fractions. 6 is 3 times 2, 4 is 2 times 2, those cancel out, and I'm left with 3 over 2, which is my slope. If the slope is 3 over 2, and I have these 2 points, I can use the slope and either one of these points to put it into point-slope form. Well, since I already labeled this x1, y1, I'm going to use this point and this slope. So I'm going to say y minus y sub 1 equals m times the quantity x minus x sub 1. That is my point-slope formula. And here's my x1, y1, so I'm going to say y minus y sub 1, which is negative 1. So I'm going to subtract a number that's already negative, equals m. My slope is 3/2, we figured that out already, times the quantity x minus x sub 1, and x sub 1 is a number that's already negative, it's negative 2. When you subtract a negative, you're adding a positive. When you subtract a negative, you're adding a positive. So I have y plus 1 equals 3/2 times x plus 2. That's terrific. It's in point-slope form, but I want it to be in slope-intercept form. So I'm going to do my distributive property. And I get 3/2 x. 3/2 times 2 is just this, 3/2 times 2 over 1, multiply straight across. Well, wait a minute, can't we cancel these 2's out first? If I multiply straight across, I get 3 over 1, which is 3. So 3 over 2 times 2 is positive 3. And over here I have y plus 1. I want to get y alone, so it looks like y equals mx plus b, so I'm going to subtract 1 from both sides. These cancel out, and I get y equals 3/2 x plus 2. Now, I'm not going to do it, but if you want to, you can graph this by starting at 2 on the y-axis, going up 3 and to the right 2, up 3 and to the right 2, and if you extend that line, you should find that this point is on that line, and this point is on that line as well. So that should prove to you that the line that connects these 2 points is in fact represented by this equation right here. Ho ho. Okay, we got 3 more. We better hustle because I'm running out of video and voice. Okay, write an equation in slope-intercept form of the line with slope -3/4 that contains the point 8, -8. Okay, I'm going to go fast. Slope is -3/4 and it contains the point 8, -8. Going to label that right now x1, y1, and this needs to be in slope-intercept form. So when I'm done, it has to say y equals mx plus b. Not ready for that yet, but I am ready for point slope. Y minus y sub 1, which is already -8, equals m, which is -3/4, times the quantity x minus x sub 1, which is 8. X minus x sub 1, which is 8. Don't let this freak you out. It's not that big of a deal. This is y plus 8 equals -3/4 times x is -3/4 x. A negative times a negative is a positive, and I happen to know that 3/4 8 times is 24/4, which is 6. If I want y alone, I'm going to subtract 8 from both sides, and y equals -3/4 x. If I have 6 positive and 8 negatives, I have extra negatives, minus 2. If you graph this line, you should find that this point is on the line, and this is the slope, -3/4. Number 10, you are renting a tuba by the hour, including a deposit. What the deposit means is you walk in the door and you say, I want to rent a tuba. They're going to say, okay, pay us this amount of money now. And then in addition to that, you have to pay so much per hour just to rent our amazing tuba. So here's what I know. If I rented the tuba for $3, it's going to cost me $38. That $38 is the deposit plus the hourly rate for 3 hours of renting a tuba. If I rent the tuba for 5 hours, it's going to cost me $50, which is the deposit, don't know what that is yet, plus the hourly rate of renting the tuba. If I rent it for 8 hours, it's going to cost me $68. That $68 is a one-time deposit plus an hourly rate for 8 hours. Now, this says if hours H were graphed on the horizontal axis, and cost C was graphed on the vertical axis, what would be the equation of the line that fits the data? So hours are on the horizontal axis. We usually call that the x-axis. Cost, total cost, is on the vertical axis, which we usually call the y-axis. They call cost C, we're going to call it y, and they call hours rented H, which we're going to call x. This is our x-axis, this is our y-axis. So we have 3 points here. We have the point 3, 38, 3, 38. We have the point 5, 50. And we have the point 8, 68. I'm going to pause and upload this before it gets to 15 minutes, and then I'll continue in just a moment.